to go through a word problem and interpret and answer these questions. So here they pretty much give us a prompt. They essentially go over, you know, they said that the distribution of scores on an aptitude test has a mean of 500 and standard deviation of 100. So the first thing I'm always going to tell you to do is understand what your givens are and write out your relevant formulas. So first things first, they have these. We have a mean of 500 and a standard deviation of 100. So we go step by step. And our relevant formula, of course, we're going to be using, we are assuming a normal distribution because we know the population standard deviation. So we're using the Z formula, which is sample mean minus population mean divided by the standard deviation. So from there, we write out our givens, which is mean of 500 and standard deviation of 100. So for the first one, it says, what proportion have scores greater than 550? The important word to understand here is the term greater. Okay, so when we write this out, we have the probability of X being, or proportion being, greater than 550. So to kind of draw it out really quickly, you need to understand that when we look at a Z-table chart, or we are looking at a normal distribution of scores, it was always going to give us the area to the left. It's always going to give us the score or the proportion of less than that score. And we're just going to put a G right here for given, because this is what it's going to give us. But then for what we are looking for, we need the area to the right because it's greater than that, right? So we're going to put this over here in green, and we're going to put need. So we know that under a normal distribution curve, it is worth 1. So when we get our answer for less than 550, we're going to subtract that from the probability of X being less than 550 to get our answer, to get to the other side, okay? So we have our formula for Z, and then we're going to fill it in, and we find a Z-score of 0.5, right? So when we go to the Z-table chart, we know that the 0.5 is 0.695. And after that, because we just said that we're going to subtract, we take 1 minus 0.6915. And that gives us a score of 0.3085 for this one. Okay. Second problem, it says, what proportion have scores greater than 700? So the key word here, again, is greater. So we have the score of X being greater than 700. We're going to draw it again. So again, we have, when we look it up, we're going to get the area to the left. So we're going to shade it in, and we're going to put G for given. However, based on the prompt, that's not what we need. We need the area to the right, and we're going to put N for need. So we know, just based on, because it's under normal distribution curve, it's worth 1. When we get the probability for X is less than 700, we're going to take 1 from that to give us the probability of the score being greater than 700. Okay, so now we have our formula, and we find out that our Z-score is 2. When we go to the Z-table chart, we're going to find that the score being 2 is equivalent to 0.9772. But of course, we're not done because we already said we have to take the subtraction of that. So the probability of X being greater than 700 is 1 minus 0.9772. Okay, so when we do that, that gives us our probability value of X, or 0.0228. Okay. We then have, what's the minimum score needed to be in the highest 10% population? The key word here is highest 10% of the population. Okay. So when we do the highest, that insinuates that the lowest would be 90%. Okay, because the top is going to be over here. So, however, we need to find the z-score that's going to give us the area of 0.9 because it always gives us the area to the left, right? Gives us the area to the left. So to find that, we need to use the z-table chart is only going to give us the area to the left. My recommendation is to use something like Excel. Okay, and when we look at something like Excel, we're going to look for something. So we put norm.s.inverse, and we're going to put the probability, so 0.9. And that's going to give us a z-score of about 1.28. We always round that to about 2 decimal places. Okay, so when we do that, we're going to plug it in here. We need to solve for x. So we have 1.28 equals x minus 500 divided by 100. And when we do that, that gives us an x equals about 628. Okay. Lastly, we have if a company only accepts people who scored in the top 60%, what is the minimum score needed to be accepted? So again, underline the important parts. So top 60%. Okay. When we do top 60% out of 1, that means the bottom part is going to be 40. So we need top 60%. We're going to get 40. That's what we're going to solve for. Okay. So again, since the z-table chart only gives us the left side, we'll need to find which z-score gives us 0.4 of the area shaded. So again, we go back to our Excel table. 0.4, that gives us about negative 0.25. Okay, so negative 0.25, and we're going to plug everything in. We're going to put negative 0.25 equals x minus 500 divided by 100. Okay, when we do that, that essentially gives us an x value of or around 475. Okay, so I hope you found this session to be helpful, or you found this video to be helpful. If you have any questions, please let me know.